Hey guys, I wanted to go over the measures of variation. That's in lesson 11-3. And we talked about measures of central tendency, and those were numbers that represented the center of the data, or what we refer to as average. These measures of variation is showing how the spread out the data is. Now I'm not going to put the date on this, but for you guys, it is the 22nd. So let's give a definition to that measures of variation. Let's see. Ooh, that went really far. Can I highlight? Ooh, yep. There we go. Cool. It's values that describe the spread or distribution of a set of data and data is separated into equal groups. In other words, we have the same amount of data in each of the sections. Okay, so we're going to be breaking our data into 4 equal groups. So that's known as a quartile. Like quarters, 4 quarters in a dollar. So data is grouped into 4 equal-sized groups. Now this doesn't mean that the spread will be the same, but the amount of data in each group is the same. And then again, we've talked about range. So notice again, here we are, new chapter, and we always seem to have a lot of vocabulary. So range describes the overall spread of the data by subtracting the least value from the greatest value. Or sometimes it's referred to as a minimum. Let's see, not by, but from. The greatest value, which is sometimes referred to as a maximum. Okay. So I think I'm going to go on to the next slide because I want to talk about the main thing is something we call the 5-number summary. So, the 5-number summary. So we can take any set of data and we can use these 5 numbers to summarize the data. So again, data has to be in order from least to greatest. So what does that make you think of? If you did a good job, you'd be thinking about median. So when data is in order from least to greatest, you can find 5 numbers. So first one, is going to be the least value or the minimum. Now I'm going to write these in the order that they'll get organized, but this is not necessarily the order that I would find them. So I'll go over that in just a second. Okay, next we can find the median of the first half. Of the data. Oops. Now he's got a name. He's called the first quartile. And we abbreviate it as Q with a sub 1. Okay? Which means we got to know where the halfway point is. So we're going to find the median of all data. Okay, and that is sometimes referred to as the second quartile. That's kind of a new term. I've always just called it median. And I've actually even seen it with a Q2, sub 2. And then we're going to have the median of the second half. Of the data. Now, if the first median was called the first quartile, and we've got the overall median is the second quartile, then this means this should be the third quartile. Remember, quartile mean quarters, and we're going to use Q and then sub 3 for that one. Now, rounding out our data is going to be our greatest value, or maximum. Now, in terms of how do I actually find these, what would be the order that I would find these data pieces? Well, first I would look for the least value, second the greatest value. Third, I would calculate the median, or find the median of the data. That's going to split my data into 2 equal halves. Once I do that, I can find the first quartile and then the third quartile. So in pink is the order that I'd actually find these. Now, what some people do investigate, though, is the distance from quartile 1 to quartile 3 is called the interquartile change. Inter, between, quartile, quarters. And range is the difference. So basically it's the difference between Q1 and Q3. In other words, we're going to just do a little subtraction problem. Okay. And this is known as IQR, the interquartile range. Now, we've been talking about this word in class, and that is an outlier. So it's a value from the data that is either much greater or less, much less than, or less than, very less than, big less than, less than. Not just a little, but a lot, than the other values in the set of data. Now, that looks like this would be a judgment call, but guess what? We actually do have a formula for this. And this is what the formula does. If we take the interquartile range and we multiply it by 1.5, then that's going to help us discover the outlier. If we have this value and we subtract it from quartile 1, so if we're IQR times 1.5 less than quartile 1, then we have an outlier. And if we have the IQR times 1.5 and then we add that to quartile 3, then that means anything beyond that would be an outlier. So again, what I would do is either take this value and I would subtract it, from quartile 1. Sorry. Or I could add it to quartile 3. So any number that goes in front of the first one or after the second one would be considered an outlier. So we're going to do some examples and we will look for outliers as we go through our examples. Okay? So first, they're going to ask us to find the measures of variation for the data. And that's just a fancy way of saying find that 5-number summary based on medians. Variation for the data. So, in other words, find the range and 5-number summary. Okay? So they're going to give us a bunch of data. So we have 64, 61, 67, 59, 60, 58, 57, 71, 56, 62. And we are going to put these in order from least to greatest. So let's see, we have numbers in the 60s, 50s, 70s. So let's start with 50s, 59, 58, 57, 56. So we'll start with 56, and then 57, and then 58. And see what I'm doing? I'm trying to line up the numbers so that I don't drop anything off. Okay, next I'm going to go to 60s. So we'll start with 60. Funny how those two lined up. Then I see a 61. And then there's a 62. And then there is a 64. A 67. And last but not least, a 71. So when I do this, then I'm one for one, putting them in order from least to greatest. Okay, so first thing we're going to do is find a minimum. So the minimum would be 56. Okay, and then we're going to find the maximum. So I kind of find them at the same time because they're easy. Once I put the numbers in order from least to greatest, 71. Next, I'm going to calculate the median. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So between the 5th and 6th number would be the middle. 1, 2, 3, 4, 5. Now, what I could do to figure out this is I could add them together and divide by 2, so I'm actually finding the mean of those two numbers. But I think most of us could probably figure out that halfway between 60 and 61 would be 60 and a half. But here's your evidence. 2 goes into 12 6 times evenly. 2 can't go into 1. And that gives me a 1/2 left over. So I can say that, or I can say the median is 60.5. And then, now that my number is broken out, this is so simple. Look what happens with quartile 1. I have 5 numbers, so there's a number physically in the middle. That's 58. And then for quartile, oops, let's try this color. And for quartile 3, we have a number physically in the middle, 64. Okay, now I am going to do range. And that's going to be the 71 take away the 56. So maximum take away minimum. And I get a range of 15. And then let's see, might as well go ahead and calculate an IQR. So we're going to take quartile 3, and we're going to subtract from it quartile 1. So let's see, we get a 64 minus a 58, and we get a 6. So between those two groups, that's going to give me my 6 values in between, a range of 6 between those two. Okay. Now remember what we talked about. I'm splitting my data into 4 equal groups. So there's 2 numbers in the first grouping, 2 numbers in the second, 2 numbers in the third, 2 numbers in the fourth. Okay, so that's pretty cool. So here's some things that I can look at my data and I can make kind of just a observation. And I could say 1/4 of the data is below quartile 1 or less than. Sorry. Okay. 1/4 of the data is between quartile 1 and the median. I can say 1/4 of the data is between the median and quartile 3, and 1/4 of the data is above quartile 3. Okay, so here's what's the interesting thing. IQR, the interquartile range, it actually covers half of the data. Half of the data goes from quartile 1 to the median, or 1/4 of the data goes from the quartile to the median, 1/4 of the data goes from the median to quartile 3. Altogether, that's half of the data. Okay. All right, I'm going to go to one more screen, and we're going to talk about outliers. So the directions are going to ask us to find any outliers. So we're going to use that formula to help us do that. So here's our set of data: 23, 48, 49, 55. 57, 63, 73. So basically, they put all of our data together in order from least to greatest, so they've done some of the work. So what we're going to need to do is to find the IQR. Well, in order to do that, we're going to have to figure out quartile 3 minus quartile 1. So let's look back at the data and see if we can figure it out. Well, in order to figure out the middle of the first half, I have to figure out the midpoint, or the median anyway. So let's see, I have 3, 4, 5, 6, 7 numbers. So this is going to be my median. And then that gives me 3 numbers to the left. So this number would be the quartile 1. And then I have 3 numbers to the right. So the one in the middle would be quartile 3. So to figure out our IQR, we're going to take Q3, which is 63, and we're going to subtract from it the quartile 1, which is 48. So when we do that, we get a difference of 15. Okay, but remember what our formula says. For an outlier, we're going to take the IQR and we're going to multiply it by 1.5. So we have 15 times 1.5. Well, 15 times 15 is 225, but we've got one digit after the decimal point. So we're looking for this number of 2.25 away, below Q1, or above Q3. So let's try it. Here's our Q1, 48, that's our Q1, and we're going to subtract the outlier formula from it. Okay, so off to the side of my paper, I'm going to do that. Annex zeros as I need to. And we get 25.5. Okay? So it says anything smaller or anything less than 25.5 is an outlier. So if you look back through your set of data, do you see a number that's less than 25.5? I do. Whoop. So that tells us 23 is an outlier. Okay, well, let's see if we have a second one. So how we do the second one is we take our quartile 3, which was 63, and this time we're going to add the 22.5 and see what we come up with. So when we add that, we get 85.5. So what that says is anything greater than 85.5 is an outlier. We look at our set of data, and the greatest number that we have is 72, so we don't have an outlier that's above our quartile 3. So on this side, there's none. So none on the right. Okay. All right. I hope that helps you with your homework tonight. Good luck now.